Everybody did grab, yeah, grab the sheet if you didn't. CJ, did you grab one? Did you grab a sheet on your hand? Anybody else not grab a sheet? Okay. Need to unfreeze my screen. All right, adding and subtracting polynomials. So Nick, can you close the computer for right now, please? I should have your attention up here, so you know how to do these. The first one is adding, or the first two are adding. So with addition of polynomials, the only reason for the parentheses are to show this is one polynomial and this is another polynomial, and you're adding the two together. So that's the only reason the parentheses are there. When you add polynomials, you just combine like terms. Okay, adding polynomials is just combining like terms. What are like terms? Divine? Yep, so like terms have, what are the two things they have to have in common to be like terms? Same what? Same variables. Divine? Yes, same exponents. So in the back, Brendan. So I know you guys moved my desks. If you're going to move them to have a conversation, then you'll move them back. Okay. I still need your attention up here though, please. So like terms have the same variables, same exponents. So as Divine said, like x squared and 3x squared are like terms. So we would be doing x squared plus 3x squared. Okay, and then I'm just going to write down the other like terms we have. So what's another pair of like terms we have in our polynomials? Casey? Negative 4x, yep, and the negative 3x, the minus signs in front make them negative. So we would be doing negative 4x plus negative 3x. And then the last one, so when you just have numbers, those are also like terms, and you keep their signs in front. So we have positive 3 plus a negative 5. Okay, and then when you combine like terms, what you need to remember is you only combine the coefficients. What's a coefficient again? Divine? Kind of. So like in 3x squared, what is the coefficient? The 3. Yep, the number in front is the coefficient. What coefficient does x squared have? 1. So you just combine the coefficients, so 1 plus 3 is 4. You keep the x squared. You do not combine the exponents. So you just combine the coefficients, exponent, variable, and exponent stay the same. So then negative 4x plus negative 3x, we would do negative 4 plus negative 3. That's negative 7, and it just stays x. And then 3 plus negative 5 is negative 2. And then all of these together, that's my answer. So the sum, or adding these together, I get 4x squared, and then minus 7x because it's negative, and then minus 2 because it's negative. And that would be the answer. Now, it doesn't ask this, but just reviewing from yesterday. So because we're adding polynomials, this is a polynomial. Is it a monomial, binomial, or trinomial? Trinomial, and how do you know that? Yep, 3 terms, so we have a trinomial. What's the degree? 2. Highest exponent. So when you only have one variable, your degree is always going to be the highest exponent. Okay, you can think of it that way. We did have some problems yesterday that had more than one variable. So go ahead, I want you to add, for that second example, add those 2 polynomials together. So add the 2 polynomials in that second example.
I did.
You have to add the coefficients. Well, this coefficient is 2. What's this coefficient? You add the
No. I didn't even know where you're supposed to do that one. Well. This is mine. Right. Right.
Okay. Some of you I know organized it like I did the top one where you wrote the pairs of like terms together. That's great. If that helps you, do that. This should be your final answer. 3x squared, 3x to the second power, plus 2x plus 1. Okay? If you had an answer, I checked while I walked around. If you didn't have an answer, are there questions in case you didn't have this? Why didn't you do it?
Because I didn't know where it's supposed to.
Oh, well, I did say you were supposed to more than once. Okay. Subtracting. Subtracting, be very careful of. Okay, I talked about yesterday how subtraction is adding the opposite. So subtracting is adding the opposite. So if you're, for example, like if you see 5 minus 3, that's really 5 plus negative 3. It's 5 plus the opposite of 3. So 5 plus negative 3 and 5 minus 3, they're the same thing. They're both 2. So we can actually rewrite this. If you see subtraction, this is going to be my recommendation, is to rewrite this so that you see addition so you can combine like terms. So to do that, when you see that negative sign there, that means there's like a negative 1 in front of that second polynomial, that second set of parentheses. And I am going to distribute that negative 1 to everything inside of that second polynomial. And then I'm going to rewrite this. So I still have my first polynomial. This is not changing. Yes. So I still have negative 3x squared plus x plus 8. Now I'm going to change this minus sign to a plus. And for my second one, I'm distributing that negative. So I did have a positive x squared, and there was a 1 in front, so it was a positive 1x squared. It's now a negative 1x squared. I had a minus 8x. If I multiply by negative 1, that's now a positive 8x. And then I had a positive 4 times negative 1 is now a negative 4. Okay, and so now that I distributed that, and this is now a plus sign, I'm adding the opposite. I just changed the sign of everything in that second one. Now I can do the exact same thing I did up here and just combine like terms. So I have, for like terms, I have negative 3x squared and negative 1x squared. If I add these together, what would I have? To the second. Yep, exponent doesn't change. I just combine negative 3 plus negative 1. That's negative 4. X squared stays the same. Then I have a plus x here and a plus 8x here. That'd be 9x. There's a 1 in front of this x, so plus 9x. And then I have a plus 8 and a minus 4. So that would be positive 4. So I have negative 4x squared plus 9x plus 4. Okay, questions on that one? You just have to remember with the minus sign. Please stop the whistling if you're whistling. Okay, just remember with that minus sign to distribute. So let's just look at another one together here. So I have x squared minus 8, and then I have minus 7x plus 4x squared. So that's a negative 1 there that I have to distribute. So I still have x squared minus 8. This is now going to be plus, adding the opposite. And then I have negative 1 times 7x is going to be negative 7x. Negative 1 times 4x to the second is going to be a minus 4x to the second. And then I combine any like terms that I have. So I have x squared and a minus 4x squared. So that would be a negative 3x squared. There's a 1 in front of this one. and then I have a minus 8. Oh, that doesn't have any like terms with it. Yep, so the minus 7x doesn't either. So it doesn't matter, it doesn't say in the directions to write it in standard form. So if you kept like the minus 8 and then you put the minus 7x, that's okay. Or like Andrew had said, the standard form would be negative 3x squared minus 7x minus 8. So either form is fine, but this one is standard form. Okay, so sometimes you don't have like terms, and that just means the terms kind of stay there, they stay separate. Okay, I'd like you to do this last example, the bottom example on there. The homework is the back side of the sheet.
See, last year, there was a thing that happened where me and Gabe were fighting over who was passing up papers.
Oh.
So he made a contract to stop it, saying like he was going to pass out papers for the rest of the year. Did she actually?
Hey, it's less work for the teacher if the students want to pass it out.
I feel like I ask every day, but like this is the time every day I have to go to the bathroom. Thank you.
It's in the wall. Like when you.